For almost 100 years, we had one simple story for how everything started. It all began 13.8 billion years ago from a single dot, so hot and so dense you can't even imagine it. Then in less than a second, boom! The entire universe just exploded into existence. This is the Big Bang. It's the biggest story in all of science, the foundation for how we understand space. It's a story of a giant expansion, of cooling down and gravity slowly pulling gas together to make the first stars, the first galaxies, and eventually, you and me. But what if I told you that story is starting to completely fall apart? What if the ideas we all learned in school are being challenged by our most powerful telescopes right now? All over the world, the smartest scientists are looking at new evidence from the edge of space. And what they're finding is freaking them out. From a universal speed limit that makes no sense, to galaxies that are way too big for their age, the story of our universe is being put to the ultimate test. These aren't just small problems. They are massive, confusing discoveries that attack the very heart of the theory. The Big Bang idea is still standing for now, but the cracks are getting bigger. And they prove our entire creation story might be way crazier than we ever knew. Before we get to the insane problems, here's what the textbooks tell you. The official name is the Lambda CDM model. Just think of it as the master blueprint for our universe. The story starts a fraction of a second after the beginning, in a crazy time called cosmic inflation. The universe, which was smaller than an atom, suddenly expanded faster than the speed of light. It was like a balloon inflating from the size of a marble to the size of the Earth in the blink of an eye. When this explosive expansion slowed down, the universe was left as a hot, thick soup of particles. For the next 380,000 years, this soup was so hot and crowded that light was completely trapped. Imagine trying to see through the thickest fog imaginable. Light couldn't travel, it just bounced around off electrons like a pinball. But as the universe got bigger, it cooled down. Eventually, it was cool enough for atoms to form. The second that happened, the fog instantly cleared and all the light was set free at once. This first flash of light is what we now call the cosmic microwave background, or CMB. It's literally the baby picture of the universe. From there, gravity took over. The best way to picture it is a loaf of raisin bread baking in the oven. The dough is space-time and the galaxies are raisins. As the bread expands, every single raisin moves away from every other raisin. No matter which raisin you're standing on, it looks like you're the center of the expansion. But everyone on every other raisin thinks the exact same thing. There is no center. The whole thing is expanding everywhere. Over billions of years, gravity pulled gas into giant clumps. These clumps got hotter and hotter until they ignited and became the first stars. These stars lived fast and died young, creating heavier elements and scattering them across space. That material then created new stars, planets, and giant galaxies like our Milky Way. This whole thing is controlled by two invisible forces: dark matter, which acts like invisible scaffolding that holds galaxies together, and dark energy, a mystery force that's making the entire loaf of bread expand even faster. This is the story that for decades has explained almost everything we see. It predicted the CMB, it correctly guessed the amount of different elements, and it described how galaxies are laid out. It's a massive win for science, but every good story has a plot twist. And in this story, the plot twists are coming fast. The first and maybe the biggest problem is so bad that scientists are calling it the Hubble Tension, and some even call it the Hubble crisis. It all comes down to one question. How fast is the universe expanding right now? This speed is called the Hubble constant. The problem is we have two perfect ways to measure it, and they give us two totally different answers. It's like two different architects measuring the same room for carpet. One measures the blueprints and gets one number, the other measures the actual room with a tape measure and gets a different one. They both should be the same, but they aren't. Method one is to look at the early universe. By studying that baby picture of the universe, the CMB, scientists can use their blueprint to predict how fast it should be expanding today. It's like looking at a baby's growth chart to predict their adult height. Based on those predictions, the speed should be about 67.4 kilometers per second per megaparsec. Method two is to measure the expansion in the local universe by looking at stuff closer to us. This is like using a tape measure on the fully grown adult. Scientists use what they call a cosmic distance ladder. They measure special stars that pulse, which tells them how far away they are. Then they use those stars to measure giant exploding stars called supernovae, which are like cosmic light bulbs that are always the same brightness. This lets them measure things across the entire universe. Here is the problem. This second method, the cosmic tape measure, always gets a bigger number, around 73 or 74. For years, scientists thought it was just a measurement error, and the numbers would eventually meet in the middle. But the exact opposite happened. The better our tools got, the wider the gap between 67.4 and 73 became. The growth chart prediction doesn't match the adult's actual height. Something is seriously wrong. Now, things are changing fast. Some new studies with the James Webb Space Telescope got a value of 70.4, which might be close enough to work. But other scientists are screaming that the tension is real and the number is still high. In January 2025, a top astronomer officially declared the Hubble tension was now a crisis. Why is this a giant deal? The Hubble constant isn't just a random number, it affects the age and size of the universe. If it's wrong, it could mean our ideas about dark matter and dark energy are wrong. Maybe dark energy isn't constant, or maybe there's a secret particle from the beginning of the universe that's messing up all our math. Whatever it is, the Hubble tension proves that our picture of the past doesn't match our picture of the present. If the Hubble tension was the first crack in the theory, the James Webb Space Telescope just took a sledgehammer to it. JWST is looking back to the beginning of time, seeing galaxies from when the universe was just a baby. And what it's finding should not be possible. According to the Standard Model, the first galaxies should have been small and messy. Imagine the process of building a city. You start with a few small huts, then villages which slowly merge over centuries to become a metropolis. The early universe should have been full of little baby galaxies. Instead, JWST is finding fully grown adults. It's like looking into a nursery and finding babies that are already 6 feet tall, or like looking back in time and seeing a fully built New York City just a few years after the land was first settled. Astronomers are finding galaxies that are huge and perfectly formed at a time when they should have been tiny and chaotic. Some of them are literally nicknamed universe breakers. Because they are so big and mature, they seem to completely break our models of how fast a galaxy can even form. One galaxy, Julong, looks like a perfect spiral, just like our own Milky Way, but from a time when the universe was only 1 billion years old. Scientists thought that was impossible. Now, some scientists argue that these galaxies just look bigger because they have giant black holes inside, making them super bright. But even with that, we're still seeing way more bright, developed galaxies than our theories ever predicted. JWST also found quenched galaxies, galaxies that just stopped making stars super early. It's like a fire that runs out of fuel and goes out way before it should have. So what is going on? It could be that stars just formed way faster than we thought, or maybe the entire rulebook for how galaxies form needs to be thrown out. The bottom line is the nice, clean timeline of the universe is being completely rewritten. If we were this wrong about the timeline, what else about the Big Bang story is wrong? This is literally science being rewritten in real time. These aren't boring questions from a textbook. These are active mysteries that the smartest people on Earth are trying to solve right now. If you think this is as crazy as I do and you want to know what they discover next, do me a favor and smash that subscribe button and hit the like button. It seriously helps us make more videos breaking down these insane discoveries. Now let's get back to the puzzles. This next problem is a little more complicated, but it is one of the weirdest. It has to do with the universe's original recipe. One of the biggest wins for the Big Bang theory is that it perfectly predicted how much of the first elements were made in the first few minutes of the universe. Think of it like a cosmic cake recipe. The theory predicts that after the first few minutes, the universe should have been made of about 75% hydrogen, 25% helium, and a super tiny amount of lithium. We checked the hydrogen and helium levels in the universe and they were a perfect match, a huge win. But then there's lithium. The recipe predicts a very specific amount of lithium-7. But when astronomers look at the oldest stars in the universe, they only find about 1/3 of the lithium that should be there. Imagine you followed a recipe that called for 3 cups of sugar, but the finished cake only tasted like it had one. Where did the other 2 cups go? For years, people thought maybe the stars were just burning up their own lithium. But the math doesn't work. Scientists even recreated the Big Bang in giant labs to check the theory, and the theory is right. We've double-checked the recipe and it's correct. So where did all the lithium go? The explanations are wild, from unknown new particles to the idea that the laws of physics themselves have changed over time. New experiments have closed the gap by about 10%, but most of it is still missing. The lithium problem is a quiet but massive puzzle. If the model is perfect for 2 ingredients but totally wrong on the third, it means we're missing a huge piece of the story of the universe's first few minutes. That baby picture of the universe, the CMB, is the most important thing in all of cosmology. Its discovery basically proved the Big Bang was real. The picture is incredibly smooth, but it has tiny hot and cold spots that were the seeds for every galaxy. The standard model predicts these spots should be totally random, like a Jackson Pollock painting of random splatters, and for the most part they are. But if you look really, really closely, there are bizarre things in the picture that should not be there. First, the biggest patterns are weaker than they should be. It's like the universe is too smooth. Then there's something so weird, they literally call it the axis of evil. I am not making that up. The biggest patterns in the CMB all seem to line up with each other. Even stranger, they line up with the plane of our own solar system. This makes no sense. It's like finding a birthmark on a newborn baby that is perfectly shaped like the house they will live in as an adult 40 years later. It could just be a crazy coincidence, but it's a weird one. There's also a giant cold spot that is way bigger and colder than it should be. In our random splatter painting, it's like finding a giant, perfectly circular blank spot in one corner. One half of the sky also looks slightly different from the other half. Individually, you could say any of these is just a fluke. But when you put them all together, it's super suspicious. They hint that our basic ideas about the universe might be too simple, and that baby picture might be hiding secrets to a much stranger story. This final crack isn't a crack, it's a massive hole that makes up 95% of everything. It's the simple fact that the standard model only works if you assume the universe is dominated by 2 things we have never ever seen: dark matter and dark energy. Imagine being told that 95% of your body is made of invisible organs that you can never touch or see, but you must assume they're there for you to be alive. That's our situation with the universe. Dark matter is the invisible glue that holds galaxies together. Without it, stars would fly off into space and galaxies would just fall apart. The evidence for it is everywhere, but what is it? The best guess is some new kind of particle. For decades, we've built massive, super expensive detectors deep underground to try and catch just one of these particles. So far, we've found absolutely nothing. Then there's dark energy. In the late 90s, scientists found out the universe's expansion is getting faster. To explain this, they invented dark energy, a mystery force pushing everything apart. It's like a mysterious anti-gravity wind that is blowing up the cosmic balloon faster and faster. It makes up almost 70% of the entire universe. We know it exists, but we have absolutely no idea what it is. Critics say dark matter and dark energy aren't discoveries at all. They are just giant fudge factors we invented to make the math work. Our best model of the universe depends on 2 ingredients that are complete ghosts. As long as we can't find them, the Big Bang theory is built on a foundation of pure mystery. With all of these insane problems, you have to ask, are there any other options? The answer is yes. A small group of scientists has been working on other models, and their ideas are starting to get a lot more attention. There are ideas like MOND, which says dark matter doesn't exist at all. Instead, it suggests gravity itself just works differently in deep space. It's like gravity is a rope that pulls things together nearby, but over vast, empty distances, that rope starts to behave more like a stretchy spring. MOND has been shockingly good at explaining how galaxies spin without dark matter, but it doesn't work for bigger things like galaxy clusters. Other models get rid of the beginning completely. There are cyclic universe theories that say our Big Bang wasn't a creation from nothing, but a big bounce from an old universe that collapsed. This theory pictures the universe like a giant lung breathing in and out over trillions of years. Our Big Bang was just one exhale in an endless cycle. It's important to say that none of these challenges has been able to explain everything as well as the Big Bang model. That's why it's still the champion. But these are no longer just crazy ideas. They are being seriously researched because of all the evidence that the standard story, as good as it is, might not be the whole story. We are at one of the craziest moments in the history of science. The epic story of the Big Bang, which has been our guide to the universe for over 50 years, is facing its biggest challenges ever. The speed of the universe is up for debate. Its childhood is being challenged by our best telescope. Its recipe is missing an ingredient. And the whole thing is held together by invisible forces that make up 95% of reality, but are still a complete mystery. So is the Big Bang theory wrong? No, it's still the best theory we have to explain the universe, but it is under a full-blown assault. And scientists are both worried and incredibly excited. Because these problems, these puzzles, these cracks, this is where new science comes from. This is how revolutions happen. Every huge scientific breakthrough started with data that just didn't fit the old story. We are living through what could be the next giant leap in our understanding of everything. The answers to these puzzles might just tweak the Big Bang, or they could lead to a completely new story of the cosmos we can't even imagine yet. The only thing we know for sure is that the universe is way more mysterious, more complicated, and more interesting than we ever thought. If you want to follow this journey of discovery, make sure you're subscribed. The universe is giving up its secrets, and you won't want to miss what it shows us next. Thanks for watching.